Hello guys, this video is about position vector, displacement, and distance, the three important alphabet quantities for learning kinematics. Later, for understanding the concept of velocity, acceleration, speed, and so forth, we need them. So let's learn them from the scratch. To start, we can consider an airport. In airport, we have a very important control center, which is the control tower. In control tower, by means of a radar, they can control the air traffic. Radar works in 3 dimensions and it's not easy to understand for now. So let's start with a very easy primitive version of that, which is just working in 2 dimensions. Suppose that this radar is able just to find the position of an airplane on the ground and it's working on 2 dimensions. In the circle, we have your range of control, and also at the center of the circle, you have your control tower. So the control tower is the center of coordinates, and you are here. Moreover, we can put an airplane here in the range, and let's establish a Cartesian coordinate system to find the position of that airplane. The position vector is a vector drawn from the origin of that coordinate system to the location of the airplane. This is the position vector. So let's establish a Cartesian coordinate system like x, y, and then let's put the object here, A, and I draw the position vector from the origin to the location of the object. To add for more details, I can have horizontal component of x1 and also vertical component of y1. Here I am going to write r based on x and y. Suppose that, let's say x1 is 11 meters, and let's say y is 12 meters. So maybe I can write r is equal to 11 plus 12. But here I have a problem because 11 is not a vector, it's a scalar. 12 is scalar. How addition of two scalars can make a vector for me? I have a big problem because r is the vector sum of this vector and this vector. But 11 is not a vector. I need to convert it to a vector. What should I do? I think I can multiply 11 by something to convert it to a vector. Something with the size of 1, with magnitude of 1, but with the nature of a vector. So let's define a unit vector. What the unit vector is? Let's say it's I. I is a unit vector with the length of 1, with the size of 1. If x is in meters, it's 1 meter. If it's in kilometers, it's also 1 kilometer, as you wish. But the nature of I is a vector. If I multiply 11 by I make a vector with the size of 11, with the magnitude of 11, but it's a vector. It's good. Likewise, on vertical axis, I can define j. J is the unit vector on vertical axis, and the magnitude is 1. But if I multiply 12 by j, here I have a vector with the size of 12, but it's a vector. Now it's meaningful to write r is vector sum of a horizontal vector with the length of 11 and a vertical vector with the length of 12. So in general, I can write r is equal to x1i, y1j. I and j are unit vectors with the magnitude of 1, but they are vectors. I is defined to the positive direction of x, j is defined to the positive direction of y. For instance, r could be 4i plus 3j. So here I can take 4 units on horizontal axis to the right, as 4 is positive, so it must be to the right. And the other is vertically 3 units upward. And then I draw the dashed lines perpendicular to x and y because it's Cartesian coordinate system. And then I draw the vector, the position vector from the origin to the location of the object. Or r may be negative 2i, negative 6j. Negative 2i means that you should take 2 units to the left on horizontal axis and negative 6 units downward to the negative direction of y. And then I draw the dashed lines. They cross here. This is the location of the object. And then I draw the position vector from the origin to the location of the object. That's all. This is in 2 dimensions. What if I confine the object to go on x-axis only, 1 dimension? It's much easier. On horizontal axis, you know that the object could be on the right side of the origin or on the left side, only on x-axis, so it's very easy to find. For instance, let's say the object is on x equals 3. So the position vector will be 3. That's all, x equals 3. And basically, I should write it as 3i, and it must be the vector like r. But as we know that it's confined to move on horizontal axis, we know that it's always on horizontal axis, so I can eliminate I and easily to write x equals 3. It's much easier. When the object is on horizontal axis but the left side of the origin, the location vector is drawn to the left, so I can put it just like x equals -4, and it's enough for me. Basically, it's r equals -4i, but no need to write I anymore, as we know that it must be on x-axis. So the position of the particle is given by its coordinate on the straight line. Let's continue with the concept of distance and displacement. This student starts from home, goes through this road, and then eventually he gets to school. As you see, the shape of this road is arbitrary. You can take any other road, any other trajectory, any other footprint or track. Anyway, the length of this journey, the length of this track is called distance. So distance is a quantity, but it's not the trajectory. It is the length of the trajectory in meters, in kilometers, units of length. Distance is a scalar quantity. If I say distance is 2 kilometers, it's enough for me that the length of the journey has been 2 meters, and that's all. There is no orientation, no direction for that. Displacement is different. For finding the displacement, you should consider a vector connecting the beginning point and the end point. So you should draw a vector regardless of the shape of the trajectory from here, the beginning point, to the end. Displacement is a vector and it must have direction. When I say displacement is 2 kilometers, it's not enough for me. I should add some more information about the direction. For instance, 2 kilometers to east, 2 kilometers northwest. It's better. Anyway, you should have a direction for that to complete the job. So displacement and distance will have the same unit, but different quantities. Displacement and distance sometimes have the same magnitude, but if the trajectory is not a straight line, we always expect that the length of the displacement, the magnitude of displacement, to be shorter than the distance. Okay? We will learn it more. Let's have some practice. Here, suppose that this object starts from here, goes to the right for 4 meters, and then continues for 3 meters up, or to the north. Let's say it's north, and suppose that this is east, okay? The displacement will be a vector connecting the beginning point and the end point, so it will be this red vector. The distance will be the length of the trajectory will be 4 plus 3, so it's totally 7 meters. What about the displacement? I should first find the magnitude of that. Magnitude will be hypotenuse of this triangle, the length of this red vector. It's going to be square root of 4 to the power of 2 plus 3 to the power of 2, which is a square root of 25, and it's 5 meters. So it will be 5 meters, but you should add the direction. Direction is north, east. It's better now. The other one could be this one. Suppose that the object goes to the right for 4 meters, again continues to the same direction for 3 meters. The length of this trajectory will be 4 plus 3, which is 7 meters again. And fortunately, the displacement has the same size, same value, but pay attention. If you say displacement is 7, it's not enough. You should add also to east, or maybe to the right. Direction is very important. The other one could be this one. The object goes for 4 meters to the right and goes back. It has a turning point here. and for 3 meters to the left. And so you see that still we have the same magnitude for the distance, which is 7 meters, 4 plus 3, the length of this trajectory, the length of this journey. But the displacement has different value. You see that the displacement will be a vector, which has the length of 4 minus 3, 1 meters, and also it's drawn to the right, so it's to the east or to the right. Okay, so pay attention. If you want to have the same magnitude for distance and displacement, first, the object must travel through a straight line, and there mustn't be any turning point. This case, you see, we have a turning point, and so the displacement and distance will have this different magnitudes. But when it goes to the same direction on horizontal axis or a straight line, both will have the same magnitude. Displacement in one dimension. Suppose that we agree that the object will move on x-axis, this number line. Okay, on a straight line, the object may displace, for instance, from -3 to the 4. So 4 is the destination here, and -3 is the initial position. So initial position xi is -3, final position x equals 4. Here I define the displacement to be final position minus initial position. If I substitute the values, final position will be 4, initial position will be -3, and so the answer is 7. Positive 7 means the object has traveled to the right. There is no need to emphasize the direction. When the object is moving on horizontal axis, x-axis, positive value for displacement also will include the direction. Evidently, the length of the journey is 7 meters here, so it's easy to understand that why the displacement has the same magnitude as distance, because the object is traveling on x-axis on a straight line with no turning point. The reverse case will be a journey from 4 to -3. Anyway, final position will be -3, but initial position is 4 here. Again, I substitute the values, final position minus initial position. Here I write -3 for final position, 4 for initial position. The answer is -7. From this negative sign, I immediately understand that the journey is to the left, to the negative direction of x. But the length of this journey will be 7 meters. Distance can't be negative. It's always positive. What if I have a turning point? Suppose that the object starts from -1, goes to the right, stops at 4, then it goes back. 4 is a turning point. The beginning point is -1 and the final position is -4. It's a destination. So the displacement vector is a vector to the left. I draw it like that, and then I write displacement to be x final minus x initial. Here the final x is -4, so it's -4. The initial is -1. Okay, the answer will be -3 meters. Okay, -3 has a negative sign indicating that the total motion, the total displacement is to the left. Finally, I can find the distance traveled. Distance is 13 meters. Why? Because the object travels for 5 meters and again 8 meters here. So generally, it must have 13 meters, the length of the journey. Let's have another case in which the object starts from -1, goes straight forward to the -4. It's a very simple case. As you see, the object travels for 3 meters to the left, so the displacement is -3 and the distance traveled is 3. As I told you, distance can't be negative. But you have a tricky case here. As you see, -3 and -3 are the same. So the displacement of these two journeys are the same, but they have different distance traveled. It's very important. So when the two objects have the same displacement, you can't say they must have the same distance traveled. They might be different. Okay. Let's consider this case. The following data are about starting point and destination of a toy car traveling on x-axis. You see it starts from 3 and ends at 12. Determine its displacement. Okay, displacement is very easy. You should draw a vector from 3 to 12. So it's a vector to the right with 9 meters of length. So displacement is 9. Positive sign for 9 indicates that displacement is to the right. Okay. Is it possible to find the distance traveled? No. Why? The reason is that you don't know anything about the trajectory. You don't know if the object goes like this, straight forward, or like this. It may have too many turning points. How do you know that? No way. So we don't know anything about the distance traveled. Just we know that it has a displacement of 9 to the right. Again, I'm grateful to you because of watching this video and being with me. Take care and see you.